Okay, free algebra, here we are, Tuesday, March, ladies and gentlemen. Wait, he is talking. The teacher is talking. Today is March 3rd, Tuesday, March 3rd, year of our Lord 2020, and we're going to quickly go through the answers to review quiz 1. I am hoping, and as I was listening and watching yesterday at the end of the period, I had a good feeling that this was so far a chapter that we're getting pretty well. Let's see how this goes. I'm looking for 11 for 11, and I'm going to call you at random. So if I call on you when we get to the late numbers, the pressure's going to be on. Ready? Number 1, Micah. Yeah. Tell whether these angles are complementary, supplementary, or neither. Number 1, look at those angles, 32 and 148. How would you describe them? No. So we're going to go 10 for 11. They are supplementary. Complementary is 90, supplementary is 180. Don't confuse those. Number 2. Let's go 10 for 11. That's pretty good. Yes. They're neither because they add up to 100. So if two angles add up to 100, that's nice, but they're not complementary nor supplementary. Oh, by the way, we haven't really talked about it yet, but why is this a thing? Why is this a thing, complementary and supplementary? Why is there no name for angles that add up to 100? Give me a common sense answer. Why is there a name for angles that add up to 90 and angles that add up to 180, but there's no name for angles that add up to 100? What's the purpose of that? Why is there a special name for the other two, Isaac?
Because those are the angles that you use to make, what are they called? Shapes, basically. Okay, because to put it real simply, straight lines and right angles are very, very prevalent in the world, right? Straight lines, you're going to use straight lines a lot. To construct this building, to construct this building, if you were to go around and find all the straight lines and all the right angles in the whole building, would you be able to do it in one day? You might not be able to do it in one day because those are two angles that are very prevalent, 180 degrees and 90 degrees. So that's why there's a special name for those. Next, number 3. One angle's 78, the other's 12. Michael, what do you think? Since we're trying to get 10 for 11 and we believe in redemption, what do you think the answer is to number 3 if it's 78 and 12? And you've been around Mr. Franklin long enough, there's reasons that he comes back to a person after they have answered a question. Usually he'll come back to that person for this reason. What do you think the answer is to number 3, Micah? Are you asking me or telling me?
Well, so yesterday I asked that.
Okay. All right. What do you think the answer is? Complementary. Very good. Number 4. One angle's 116, the other's 64. Supplementary because they equal 180. Hello, Jordan. How you doing? Number 5. Can a triangle have these measurements? We did this one yesterday. So even if you didn't, you could have written the answer to this and not even knew what you were talking about. Because I answered this openly yesterday. What'd you get for 5, Jordan?
No, because it doesn't have a
Right. They have to equal 180. All triangles have to have 180 degrees sum total. How about number 6? Spence?
Yes.
Yep, they equal 180. How about number 7? Noah?
Yes.
Yes, they equal 180. Number 8. What does X have to be? Cameron?
45.
Right. Because X plus 3X has to equal 180. Right, David?
Yeah.
They give you two angles there. One's X and one's 3X. If you add those two together, they make a straight line. Well, 1X and 3X is 4X. How do you get rid of the 4? So X is 45. Next, number 9. What is X? That shape is a trapezoid. It makes it a quadrilateral. Knowing that a shape is a quadrilateral, Zacchaeus, gives you valuable information. It tells you the total number of degrees in the angles. What's the total number of degrees in any quadrilateral?
No,
The total number of degrees in any quadrilateral. 360. So from that, Casey deduced that that angle left over is 125. She added the 3 angles, subtracted it from 360. Number 10. What is that shape? It's a strange looking shape. What is the shape? It's a hexagon. It's not a regular hexagon, obviously. Because if it was regular, all the angles would be the same. So it's a hexagon, strange one, and they've given you 5 measures. What do you know about any hexagon? 6 minus 4 or 6 minus 2 is 4. And 4 times 180? 4 times 180. 720. So if you add up all the angles they gave you, wait, they only gave us 4 angles. Or did they? They gave you 5 because they gave you 4 numbers and a indication that that one angle is 90. So what'd you get left over? I said I was going to call it random. LP. What's X in number 10? 132. Last one. 2 angles in a triangle measure 75 and 30. What's the other angle have to be? Brett. 75. Great job. We did well. Did we get 10 out of 11?
Yeah.
We got 10 out of
I got
11.
11. I didn't get 10.
And if it wasn't for Seth, we would have got 11 out of 11, right, Micah?
Yep. Yesterday, he told me that.
Micah, what was your answer?
What?
Number 1. So you're saying you originally had the right answer and you changed it.
No.
Oh.
No, because yesterday I was using the complementary and supplementary, and then he told me the wrong one, so I got.
And you asked me and I said no.
All right. We got it straight now, Micah?
Yeah.
All right, here we go. We said this word last week when we didn't have to say it yet. If 2 things are the same, most of the time we call that equal. But in geometry, we try not to use the word equal. We use the word congruent. Congruent means they're the same. Same what? Same size and shape. So if 2 things are the same size and shape, they are congruent. So if I drew a line on the board, and I drew 2 lines on the board, one was 6 inches and one was 6 inches, would they be congruent? Yeah, because they're 2 lines of the same shape and they're the same length, so they're congruent. If I drew 2 triangles on the board and they were both equilateral triangles, would they be congruent? Yes, no, or maybe so? Let me ask it again. If I drew 2 triangles on the board and they both were equilateral, would they be congruent? Your choices are yes, no, or maybe so. Mitchell, maybe so, because I'm not the greatest artist, but if I drew a triangle and all of these were the same, by the way, we learned that if all the sides are the same, that means all the angles are the same. So an equal angular triangle is also an equilateral triangle. Okay? So if I drew that triangle and this triangle, are they congruent? No. They're both equilateral and they're both equal angular. They're both the same degrees in the angles, but they're not congruent. Why? They're the same. Look, 60, 60, and 60. All of those angles are 60. Why are they not congruent?
They're not the same size.
Because they're not the same size. They're the exact same shape, but not the same size. And in geometry, we would call these not congruent, but, anybody know the word? Similar. Very good, McPhee. They're similar, but not congruent. All right, they want you to be able to listen. There's a little bit different thinking in geometry. Elise is supposed to be able to look at the two triangles, the green ones, in the middle of page 397, and she's supposed to see that those are the exact same triangles, even though they're quote-unquote facing different directions. Raise your hand if you can see that those triangles are exactly the same. Most hands are up. Dina, I'm not sure. Looks like she might be working on a different subject in math. Let's see. Rule number one, it does say 5th grade rule, so maybe she got confused. Be prepared and be here now. And we're in math right now. Okay, so the green triangles, are they the same exact triangle? Some of you are saying no. They are the same exact triangle. I want you to picture doing this. Ready? Picture taking the one on the left and flipping it over and imagine it going right on top of the one on the right and matching it perfectly. Do that right now in your head. Visualize that. Taking the triangle on the left and flipping it over, and it would cover the one on the right perfectly. Raise your hand if you see it. Okay. Even if you don't see that, you have been given information to tell you they are congruent. The tick lines, 1, 2, and 3, see them? 1 tick line, 2 tick lines, 3 tick lines. When those are given to you with two different shapes, I'm telling you that those, listen for this word, ready? Here comes a big word. Those corresponding parts are the same. Corresponding, that's a tough word. Think about it. What's it mean? Does it mean opposite?
Oh, they're like the same, but different.
They match each other. Corresponding, matching. You with me? So, what line matches, which two lines match each other in those triangles? If you look at the triangle on the left, it's the right side of it, matches the triangle on the right's left side. You see that? They're exactly the same. It's just they're facing different directions. Corresponding angles are congruent. If you've got two triangles and their corresponding angles are congruent, then the triangles are congruent. Make sense? Bottom of page 397, they show you quadrilaterals with the same information. At first glance, you might not think that the top and bottom are exactly the same. Or maybe you could see that right away. I want you to be able to look at that and say, the top panel and the bottom panel are exactly the same. Can you see that? The left side and the right side are exactly the same. Can you see that? What would that tell you? That would tell you that Q is exactly the same as, look at it, raise your hand when you know the answer. Q is exactly the same as, no. Q would be exactly the same as E.
But isn't the one on the right flipped like upside down? It's R and F
And A would be exactly the same as J. J. Everybody got that? Everybody see that?
Yeah.
What would be the corresponding angle to, let me see, one that they don't have on there. G. What would be the corresponding angle to G? N. Everybody see that? Turn the page. Okay, so now we're going to use this information. Example 2 says, now that you see that, you'd be able to tell me the measure of the angles in these two triangles, knowing the measures of one triangle is going to help you know the measure of the other triangle. It tells you, first of all, that the triangles are congruent. Is that important to know? Hello?
Yes.
That seems like a very basic question. They had to tell you up front that JK and L and TSR, what symbol did they use for congruent? Congruent is almost like being equal. So what's the symbol? Equal sign with the little squiggly on top of it. That doesn't mean equal, that means congruent. So the triangle on the left and the triangle on the right are exactly the same. First of all, do you see that? Listen, when I used to take those, you know those tests you guys take, ACT and all that stuff that you're going to take pretty soon, and the Terra Nova stuff, my worst category was a thing called spatial reasoning. Being able to see stuff like this when I was younger was very difficult for me. That's why I keep asking, do you see it? Do you see that the one on the left and the one on the right are exactly the same? They're oriented differently, but they're exactly the same. Questions like this were always on those tests. Okay, so knowing that, the sum of all triangles, the sum of the angles is all triangles. Sum of the angles is 180. So if they gave you 31 and 25, what's the measure of angle K? Let's work through this. What's 31 plus 25? Okay, so what would K be? K would be 180 minus 56. So having said that, if 180 minus 56 is 124, what's the measure of angle S? Hands. If we figured out that K was 124, 180 minus 56, my question to you is, what's the measure of angle S? 124. Because angle S, what's the big C word? No, corresponds to angle K. Raise your hand if you're lost. Raise your hand if you're not lost, but you like to say you're lost every time something new comes along. You're looking at me. You're looking at me. All right, everybody got that? Your turn now. Numbers 2, 3, and 4. Go. 2, 3, and 4. Middle of 398. I'll put them on the board as soon as I'm done erasing. Jordan Wright will be done with 2, 3, and 4 by the time I erase and put the answers. No. How are you trying to kid?
That would be awesome.
She says it's this homework.
I know. 31.
Some of you aren't even working. How are you going to be done before I get there? Oh. Hey, you should be done. Raise your hand and tell us why those are the answers. First of all, if you didn't get these answers, we got to fix that. The answer to number 2, please stop the chatter. The answer to number 2, ST is 10 centimeters. If you got 10 like I did, tell us why you got 10. Kira.
Because if you flip it upside down and around the other one.
True. Now tell us why it is true with some vocab that we learned here this morning. Use the proper vocabulary to tell us why ST, that line segment, is 10. Kiara. There's another big, longer C word we use to tell us why ST is 10. ST corresponds with JK. Focus. Everybody see that? ST, Micah, do you see that ST corresponds with JK?
Yeah.
You just saying that?
No.
You're focused.
Yes.
All right. Number 2, Micah, tell us why angle T has to be 31 degrees using good mathematical language.
Well, that triangle is the other one. So
We're afraid of the word. Bella. Okay, go ahead, Micah.
Well, the one, this triangle is corresponding with this triangle, so the angles are the same.
So why is angle T 31? Because angle T corresponds with angle J. Number 4, why is the answer 25 degrees? Using good mathematical language, Isaac.
Because J is the same.
Number 4.
No, because L is the same as R.
Let's use some good,
When you
what's the long, big word, starts with C.
horizontal.
You haven't been here for the last 5 minutes. Somebody tell me with the good mathematical language, Brett.
So R corresponds with L.
Angle R corresponds, Isaac, with angle L. Angle R corresponds with angle L.
Wait, I'm confused.
Here we go, David. Ready? Number 2. ST, that side of the triangle, corresponds with JK. This one's not as easy to see visually. The other ones, we've been able to go like this. I'll just flip it right on top of the other. I'll flip it right on top of the other. This one, you would have to turn. This one, you would have to rotate. Here's what you got to do in your mind if you're trying to see this. Take the point S. Follow me here. Everybody look at the point S. In order to see how these two are perfectly congruent and one would fit right over top of the other perfectly, picture taking the point S and going counterclockwise and putting it on top of the K. Everybody see that? If you can visualize that, those two triangles would overlap each other perfectly. Take the S counterclockwise and put the S on top of K, and it would be perfectly overlapping. Yes?
Wouldn't you just flip over the right triangle and put it on top of
It would be upside. What do you mean? You can't just flip it because it's upside down. Take the S, counterclockwise. All right. Very important. There's 3, gentlemen, there's 3 ways to prove in geometry. We can't go by how something looks. We have to prove it. And when you take actual geometry, freshman or sophomore year, you're going to have to do these things called proofs, where you know the answer. And a lot of you that like to, back in 5th grade, no, you just can't write the answer. There's certain things I have to make you write out, because when you get to geometry, that's the grade, not the answer. The thing's called a proof. You have to have every step done just like it's supposed to, because it's not important to just know the answer. It's important to know how you got to that answer. That makes sense? So there's things called proofs. So there's ways to prove that 2 triangles are congruent. One is that all 3 sides are the same length. One triangle to another, all 3 of the sides match each other. That's called S, S, S. Because all the words start with S, because all the words are side. Read that description. It says, if 3 sides of one triangle are congruent to 3 sides of another, then those triangles are congruent. Follow that? What's that called? SSS. The next one, SAS. If two sides of a triangle, listen, it's not just two sides in any angle, it's two sides and the angle between them. Two sides and the angle that they create. So, if we said that these were two sides we were focused on, if two triangles have two sides that are the same length, and the angle in between them is the same, then those two triangles are congruent. What do we call that? Side, angle, side. Okay? Third one. If two angles are the same, if we had a triangle where two angles were the same, and the side in between the angles was the same. In both triangles, the triangles are congruent because of angle, side, angle. A, S, A. Everybody got that? Let's see if you can do example 3 or understand example 3. Name the congruent triangles formed by the bridge cables and explain how you got that they are congruent. Let's follow their process. Ready? Do you see that CB and CD are congruent?
Yep.
Everybody see that? Okay. Why? Because the tick marks tell you they're the same. Not because they look the same. Hello? Listen, this is the hardest thing. You can't go by looks. There has to be proof. I mean, you're building a bridge, or let's say you're building a building. You can't go by, that looks about right. It has to be precise, right? So the tick marks tell you that they're the same. So BC and CD are the same. Also, AC is the same as AC. Now that sounds silly. Raise your hand if you think that sounded silly. Nobody's paying attention. If you didn't think that sounds silly to write that down, you're not paying attention. Why did they write AC is congruent to AC?
Because it is.
In the middle?
Why would you have to write that?
To prove
To prove what? Shh, listen.
that they're equal.
That what? No, not equal. I'm not using that word here.
Congruent.
That what's congruent?
There's AC.
It's not an angle. It's a line segment.
Okay.
Come on, stay with me. Why was it necessary? They're trying to prove that the two triangles are congruent. Why is it necessary to write down that AC is congruent to AC? Isn't AC AC? Why was it necessary to write that down? Because in order to show two triangles are congruent, you have to have proof. What are your three proofs? Three sides are the same length. Come on, focus. Another proof would be side, angle, side. And another proof would be angle, side, angle. Which proof do they end up using in example 3? Go ahead, look at the bottom. Which one do they end up using? Okay, side, angle, side. Stay with me here, Ethan. First, they had to prove that CB and CD were congruent. How did they know it? They were told by the tick marks. Then they had to prove that the vertical line, AC, was the same in both triangles, even though it's obvious. They share that side. So if that side's equal, and the bottoms of the triangles are equal, and what else did they tell you? They indicated that the angles created were right angles. So they told you that side, angle, side were the same, therefore the triangles are the same.
What about
I feel like I'm saying something that's really simple, and you're all sitting there saying you got it, but you're not really thinking it through. Because you're gonna get triangles that are not connected side by side like that, and that you can't see so easily are the same. And you're gonna have to be able to tell me that they're the same using that proof. Side, angle, side. Well, there you go. Here's your work. Numbers 1 through,
For one, look at that.
I actually had 1 through 19 written down. We'll go 1 through
So,
14. 1 through 14. Yes.
for the bridge order,
Yeah.
you have, how do you prove that A and AB and
A, B, and AD, you don't have to prove. Listen, ladies and gentlemen, the question was a very good question. Kara asked, how do you prove that AB and AD are the same? Because if you're saying both triangles are congruent, then don't you have to prove that all parts are congruent? The answer is no. Because, Kara, that was a great question. You don't have to prove that AB, Kara, you know what's good about your question? Is that you're actually thinking, because out of the 26 kids in here, only 19 or less than 19 are actually even following your question. They're just going into their work. They're not even understanding what you're asking. Kiara said, why do I not have to prove that AB is congruent to AD? Or she didn't say that. She said, how do I know they are? Well, the point is you don't have to prove they are. You've already proven that the two triangles are congruent by way of side, angle, side. Once you have proven that two sides and the angle created between them are congruent, Kara, then you've already proven that the other sides are congruent. There's no other way it could be. I feel like I have to repeat it because there's still some people that have no idea what she's asking.
Yeah.
You don't, do you? Thank you for your honesty. Look at the picture. Did we prove that that BC and CD are the same?
Yeah.
Just keep looking at the bridge. Did we prove those two are the same? How did we prove it? What did they put there? They put the two tick marks to tell you they're the same. You with me?
Yeah.
You sure?
Oh, yeah.
You're just saying that. Rachel, do you see the tick mark between B and C? And the tick mark between C and D?
Yeah.
Okay, that tells you they're the same, right?
Yeah.
Okay, how do we know AC is the same in both triangles? Because it's the same line, right? You with me? And then how do we know that angles 1 and 2 are the same? No, we're not going by looks, or if we flip it over. How do we know for a fact that 1 and 2 are exactly the same? They're what? You gotta be more specific here. How do we know for a fact that angles 1 and 2 are exactly the same? They're what? What are the red marks? Okay, so you just said they're angles. You didn't say right angles. So angles 1 and 2 are right angles. They're exactly the same. The bottoms of the triangles are exactly the same, and the middle line is exactly the same. Kira is saying, how do we know that the tops are the same? And the answer to that is, we don't have to prove the tops are the same. We already know they are. Because if you have side, angle, side being congruent, then the whole thing's congruent. You don't have to go that extra step to prove that those two are the same. David, what number are you on? 12? What'd you get for 1? What'd you write down? What? I don't see that on the paper. Okay, so what'd you get for number 2?
I don't know.
Blank are in the same position in different figures.
Oh.
There you go. Corresponding parts, bud. Corresponding parts are in the same position in different figures. You've got two different figures, a triangle here and a triangle here. Corresponding parts are in the same position, even though they're in two different figures. Yes?
Yeah, I'm doing way more shape. I just no, I did 12 wrong. I thought 12 saw some of the shapes above it. And then I saw
12?
below it. Yeah. So I'm at 12, but it's moved on to 13.
Oh. When they say justify your answer, they mean prove it. Prove it how? There's three ways we learned how to prove that triangles are exactly the same, congruent. One is side, side, side. All the sides are the same length. The second one is side, angle, side. Two sides with their angle they create being the same. The third one is angle, side, angle. The side that's between the two angles that are congruent. That's the three ways you had to show to justify, to prove that the triangles are congruent.
I remember that.
And number 12. By the way, I'll give you a hint. There's only two answers to number 12. They give you 5 triangles, and there's only 2 pairs that are congruent to each other.
So I did. Oh.
So we could have done, there was plenty of time to do through 19.
No.
Oh, we got,
No.
I mean,
Mr. Smarty Pants got his book closed already.
I bet he guessed on 9.
Yeah.
Yeah, I think we should just do it.
I'm on number 8.
Look at it.
I think we should just do
Yeah,
it.
it's
No, I think we should.
The bell.
17.
The number 12.
What do you call the triangle? ABC, right? We name it by
I didn't do it.
1 through 14.